Welcome to a very special episode of SimPac Live. I'm your host, Jeff Matthews. Today, as part of the Sim Europe conference program, we're about to talk about the decarbonisation of steel production with Dr. Paul van Beurden, who is a principal researcher for Tata Steel R&D in the Netherlands, and Hilbrand Kuken, who is the CEO of Quantillion. Last year, direct emissions from steel production were estimated to be at 2.6 billion tonnes of CO2, representing between 7 and 9% of global emissions. Tata Steel are the 10th largest steel producer globally, with a steel tonnage of over 30 million tonnes and revenues of over US 30 billion. This means Tata is responsible for over 57 million tonnes of CO2 per annum. To put that in context that we can all understand, that's the CO2 equivalent to the annual emissions of over 12 million cars. Fortunately, Tata take its emissions responsibility seriously and have embarked on R&D across the board to look at CO2 reductions. Today we'll focus in on one such project being run in the Netherlands to reduce emissions in just one aspect of steel production. Welcome, gentlemen. Thank you for joining me. Hilbrand, firstly, your company's tagline is industrial strength software, which I love. I love the tagline. Can you explain to the viewers a little bit more about what your company does and the tagline?
Yeah. Thanks, Jeff. Thanks for inviting me for this interview. So Quantillion helps heavy industry, mainly steel, aluminium, to basically automate their processes. What we see is more and more processes are being automated. We see a lot of vendors and equipment suppliers focus on automation. And basically what Quantillion focuses on, how do you bring all operators, machines, equipment, and everything inside your factory together to basically create the optimal process flow inside your factory. Our main focus there is on flexibility, because what we see is in the heavy industry, there's always things going wrong inside your process. There's unplanned things happening. And basically what we see is if you want to automate, you need to be able to respond quickly to changes inside the environment. And basically what we focus on is autonomous decision making inside factories. So we basically optimize planning, scheduling that happens inside factories, making factories more flexible in their processes and basically ready to automate even further in the future.
Because efficiency is going to help us get to decarbonisation. Having our industrial process more efficient, more flexible, and able to introduce new technologies faster and quicker that's ultimately going to help us get there.
Yeah, exactly. So we see this as one of the fundamentals to go through this change. And if you think from a factory perspective, knowing you need to adapt your processes towards more sustainable production, those are big capital intensive projects that you have to go through. And basically all those new processes, they need to work together and connect in the future as well. So with that, all those new changes that you will have to go through, they need to be able to connect in the processes and in the planning in the future as well. So what we see is we will see coming 10 years, a long investment in different projects that will help reach the sustainability goals. And in the meanwhile, you need to have a foundation underneath where all this decision making can be caught. And that's basically what we help. And what we see is with current programs and planning, it's too rigid. It's very difficult to adapt to changes. And with our planning software, we are able to help those factories also be basically ready for the future for all those basically investment in sustainability projects.
Right, thank you. Now let's come to this project. You've embarked on a project with Tata Steel, the R&D from the Netherlands, Paul's area of expertise. Paul, tell us about this particular project, the genesis of it. Where did the idea come from? Because I know the IEA are saying we need to deploy a range of technological solutions because decarbonisation of steel, it seems every bit of the process needs to be decarbonised. There's so much involved in it, and it's not like some industries where you just have to move to renewable energy. This is there are CO2 emissions embedded in the process that you have to get out.
Yeah, thank you, Jeff, indeed, for giving me the opportunity to speak here. You're absolutely right. The steel industry is very CO2 intensive. We're currently in a transformation to making steel based on hydrogen, but that only covers up to, say, 60-70% of our CO2 emissions. So there's still a need, a necessity to reduce CO2 emissions further, and energy efficiency improvements is one of the important factors that can contribute to that. So there's absolutely a need to be more energy efficient, and that's where this technology, which Hilbrand addressed, comes into play. We have our own models, our own insights, our own data. But with this kind of digitalization technologies, decision support systems, we can make smart decisions based on facts rather than on intuition. We can speed this up.
And so, give us a description of what this. For somebody who doesn't know much about steel production, this is about the energy efficiency of taking the steel once it's come out of the furnace, and it's sent in these torpedoes on a train, essentially, to the cast house. And every minute it's out, it's dropping in temperature, and that requires it to be reheated at the other end. That's correct?
That's indeed one of the aspects. In addition, when you save temperature, that means that you can add scrap, basically recycle waste steel. So, which reduces temperature. So the more temperature you already have available in the process, the more you save, the more you can increase your circularity and reduce CO2 footprint without needing to heat up additionally. So it's saving on temperature losses means possibility to increase circularity.
And so this project was focused on the reducing temperature loss in this bit of the process, and that would allow you to use increased amount of recycled steel, which has got a low CO2 footprint, and every degree you saves fossil fuels and trying to reheat it back up to temperature again. And so it was an energy efficiency and conservation to lower the CO2 content of it. And also, I'm assuming, to prepare for hydrogen to come in, because eventually those fossil fuels are going to be replaced by hydrogen, which it looks like hydrogen will be more expensive than fossil fuels. And so the more efficient you can make the process, the cheaper cost it's going to be in the end anyway, once you decarbonise that bit of it.
Absolutely. Yeah, that's indeed the other aspect. So there's also a cost gain. So they work together. You reduce your CO2 footprint, and you also reduce your cost, because you need less fuels to reheat up in the production process itself. Yeah, that's a win-win in that sense. Absolutely.
Right. So coming back to Hilbrand, tell us the complexity of this. It sounds simple on the outside. I love making things simple, but I'm sure it wasn't simple. And what were the complexities that you had to deal with in terms of what you brought to the table in your industrial strength software?
Yeah. So first of all, I think we have to look at the process that you just described. Tata Steel developed on their end an accurate prediction model on this temperature loss. So they, on the R&D side, have been developing a method where they were able to more accurately decide how the temperature loss will go. That is technology that obviously Tata Steel has been developing in-house, and that is something where you need to have the knowledge on this steel temperature loss, which is usually inside, let's say, factories like Tata Steel, where this knowledge is based. However, to basically get the business gains on these temperature models that was developed by Tata Steel, you need a decision platform, which basically decides how will all those torpedoes between the furnaces and the Oxy Steel factory, how will they plan? Because basically the initial thinking is if you want to gain, let's say, the CO2 emission and also the cost aspect that Paul's referring to, you need to basically translate it into actual actions on site. And that's exactly where Quantillion came in. So we have a planning platform, basically, which makes use of this prediction model developed by Tata Steel. So we look into the prediction model, and based on those predictions, we say this is the best chain of actions that you need to go through to create a minimal heat loss on these torpedoes. And the critical key is there. If you look at all the possible actions that you can take, let's say coming 4 hours, it is already quite extensive to calculate that. And at a certain point, regular mathematical methods are unable to look further in those actions, and basically you cannot find an optimum. So what we did for that part of the puzzle, we used reinforcement learning, which is an AI model that can look even further basically into the future. It can take even more actions in the future into consideration to reach an optimal action list. And basically, that is the method that we use to coordinate those torpedoes, and with that, the optimal temperature loss.
So how many torpedoes have you got in play at any one time? There's a large number, I assume, and they're all varying temperatures, and the heat loss is going up and down, and you have to juggle these things.
Yeah, exactly. So.
Correct. Yeah.
Usually there are around 22 torpedoes running. There's a lot of dependencies in there, which creates basically how the temperature loss will look like. Of course, there's the physical constraints on the train track, and not every action is physically possible to perform because torpedoes might lock into each other. And we basically use this process to test this technology, because we know this type of technology, this reinforcement learning planning, is applicable in multiple processes inside the factory. And the key thing is there, reinforcement learning is really quick. So you can quickly adapt to changes that will happen on site. And from experience from other industries like aluminium industry, where we implemented these fully autonomous decisions models before, we know being able to adapt quickly and find the next best scenario, that is critical and key to basically look at the total temperature loss in all those 20 to 22 torpedoes on site. And also you can look into the energy loss from a total perspective on these during these transports.
Right, and your AI learning, is this very similar to a digital twin, or is it the same sort of thought process of that?
Yeah, I think everybody uses words like digital twin, but basically that's exactly what we do. We build a replica of the exact environment. We test basically how the current process is going. So we use a FIVO algorithm, first in, first out algorithm that is being used by Tata Steel right now to do those transports. Then we validated that method with the customized heuristic algorithm. That's basically a mathematical model which helped us to enable and validate the FIVO method if how the performance looks like. And then as a comparison, we basically build a digital twin where we use this reinforcement learning model, where you can test multi-million number of scenarios in a quick period of time. In a couple of hours, you can basically calculate all possible outcomes, and we use this reinforcement model to find the optimal chain of actions to reduce the heat loss. Right.
And Paul, coming to Tata Steel, steel making's 125, 135 year old industry, a little bit like aluminium. so there are people, your crew and your staff on the ground that are sort of what I call third generation engineers. They've been taught by engineers, have been taught by engineers, engineers of how to do something one particular way. Were they welcoming of this project to look at doing it in a better way? Were they open to that from a human resource point of view?
It's the change management is definitely a challenge in general, I think, for digitalization projects, and this is no other project in that sense. What we do is involve and engage as much as possible with the operators involved. They have of course, there are general operation rules, but our operators they are so skilled, so professional in their job. They have a feel of how things. They do have an intuition developed for the process, which we do need to take into account into these models. Otherwise, they will never work. So their contribution is really important. Is key to making this work and to get the best out of it. So they're definitely part of the project. They're involved, and in the end, they will be using this technology to support them. It is not a matter of replacing people or resources. It's definitely not the aim. It's together. It's giving them the tools to improve their job, essentially.
Yeah, and within Tata Steel, this project is. Did you approach it? Is it part of a whole series of projects of looking into it, or were you looking at for low-hanging fruit? Were you looking for the easiest stuff, which I'm in favour of? I think everyone should go for the low. It's the fastest way to decarbonisation is to be able to do something today, not plan to do it in 20 years' time. And so, was it considered low-hanging fruit, or how does Tata Steel structure the bigger picture of where this project fits in?
This is an excellent question. Thanks for asking. You're right. The faster we can put these kind of technologies, these measures into action, the better. I don't think low-hanging fruit is. There's a lot of high tech involved and a lot of sophisticated modeling, but it is definitely part of a bigger picture. At Tata Steel, we at R&D we develop models, high fidelity models for a lot of process steps. How to get insights in the energy efficiency characteristics. By piloting this technology in combination with the reinforcement learning models, as Hilbrand explained, we can optimize this part of the process real time and support operators. This is the pilot project, but this is definitely transferable to other parts of the production chain. So that's the importance of this project. It's demonstrating and it's developing knowledge and expertise with this kind of operation, decision support operation, and this can be transferred to the essentially entire production chain.
And in terms of outcomes from this project, how successful was it? I'm assuming, hopefully, that this is going to lead to more things, and it's going to go on.
Yeah, absolutely. So up to now, we managed to reduce the temperature losses substantially with these models. We're talking here for every million tons of steel you would produce. We're talking here about savings in CO2 of say 5 to 10 kilotons per year, typically. So depending on how much you produce, this adds up. In terms of cars, this is around 5,000 cars per year for every 1,000. 1 million tons of steel you produce. So it's very successful. We're already saving much more than this. And if you would transfer this to the entire production chain and other parts of the process, the savings will be definitely substantial. Yeah. So it's very successful.
And one of the things I love about this project is that it's actually saving OPEX, it's saving cost. as well as decarbonisation, because every bit of efficiency you can get, every bit of temperature gain or temperature you don't lose is saving of fossil fuels. You've got to reheat it. So, and I assume it doesn't seem to be very capital intensive in terms of an operation. You're not rebuilding a smelter or building a new power plant. So that's sort of, in my term, it might be high tech, low-hanging fruit, but it's something you can do today that doesn't require massive capex, reduces your OPEX, reduces CO2. Everyone's a winner. That must be a good feeling within Tata Steel and your R&D division.
Yeah, absolutely. Yeah, that's absolutely right. In that sense, you could say it's low hanging fruit, especially to compare to our transformation to hydrogen-based steelmaking, which indeed involves a lot of capex. So it's fast. It's doable if you have the insights of the thermal behavior of your installations. You can start right away and have this done, say in 1 or 2 years max, and you have these savings already in action. Yeah.
Beautiful. Hilbrand, this type of modelling and technology, I'm assuming the learnings that you found are transferable across other heavy industry, because all heavy industry deals with high temp heat in some form.
Yeah. And I maybe want to emphasize on the fact that the way we cooperate between Quintillion and Tata Steel has been terrific. And I think that has been one of the learnings as well. So what we see, and we see that in other industries as well, there's a lot of knowledge inside this industry that is sometimes difficult to tap into. I think maybe looking back, it has always been a quite protective approach. So this knowledge was being protected as one of the critical elements for their production. And what we see now is we see the industry slowly opening up a little bit, and they start understanding that collaboration on, let's say, these kind of prediction models that were developed in-house and decision support systems that companies like Quintillion can provide, that is a critical thing to create these business cases and to actually create these gains inside the production process. So I agree with you. It is compared to all the projects that the industry needs to go through, it's less capital intensive compared to those projects. And I think there's one other big plus. It enables you to basically add other new prediction model and technologies to this platform in their decision making. So it's an enabling technology for further optimization in other processes as well. And once you have that installed, it is really easy, basically, to add those new models to your decision making.
I want to come to a point about sharing knowledge and research. You said you had this great sharing between Tata and Quintillion, and I've got both of you on screen, so I'm assuming it's going really well. But what about within the industry? We've only got essentially 26 years left to 2050. The job of decarbonising steel is just a huge mountain. And a couple of weeks ago, and I know I talked to both of you about, I was in Shanghai and I gave the keynote address to the AZ Global International Aluminium Conference. And I said, we've got to share research. We've got to collaborate. We've got to share our dead ends as well. We don't have time for all the companies to go around researching something and come to the same dead end conclusion. That's just wasting years we don't have. Is there, and this might be, both of you might chime in here, is there a willingness in the industry to share some of this research in that we could do this and we could save X amount in temperature and save this by optimizing that, and this is a great way to go? Is that something that's going to come out, that's going to be shared?
Yeah, absolutely. The first phase of this project was the results and the approach was published in a report available to the public. We also present this project on conferences, for instance. So we're open to be approached by other steel companies, for instance. We're participating in European projects in consortia, where we employ similar concepts, similar technology. So definitely, there's a need to decarbonize, and I think the steel industry is well aware of that. And you do see these kind of collaborations and sharing emerging.
Yeah. To add to that, I think it's a responsibility that we don't try to compete on these technologies that is working towards more sustainable production. Instead, we should share this knowledge so everybody can gain on this. And I think what we try to do here is find methods how to cooperate, test this technology if it is feasible or not. And my experience in the industry is once you show that it is working and it's operational, others will follow. So it is not our intention to basically keep this knowledge to ourselves. This is one of the reasons we sit with you here today and be interviewed about it, because we want to share this knowledge further. And if other steelmaking industries can use this type of thinking and these kind of projects, we are happy to share and see what we can do.
That's great. It's really great news, and thank you. Both for coming on and both for sharing that, because the old paradigm of trying to lock something up in a patent, inventing a process and patenting it and locking it up for 20 years. We only got 26 to 2050. If it's going to decarbonise the industry, it's almost like we've got to rethink our old mindsets. So now, question for both of you again. From what you learned in doing this project, have you got any advice for other companies looking to embark on projects like this? I mean, I know that there's Tata's a big global company, 30 plus $1 billion turnover, and it's contracted Quintillium, which is an outside external resource, to help them with something. That's a collaborative model in itself, because there's a lot of big companies choose to do things in-house and they don't get that outside. But what were the lessons learned that working together? What would you say? What was the advice you would give somebody else?
I think the advice is try to find a good business case first. This allows you to basically install some of this technology. Then basically with that, you have a foundation to further build on. And I think that approach showed quite successful in our collaboration. And I think that would be one of the recommendations to other industries who are looking into, let's say, more sustainable production in the future. I think that approach, try to create business cases and basically plow back those gains into further development. I think that has been quite helpful.
And I think from our side, or from the industrial side, I can say, well, there's a lot of data and knowledge and experience available, which is not capitalized or can be used to make huge steps towards energy efficiency, sustainability, and decarbonization. And these digital tools, this artificial intelligence can really help with that. So combining the expert knowledge, the experience, everything available, which is already available in industry, this is a beautiful way to capitalize and to achieve sustainable your sustainable goals. It's already there.
That's great. So we're going to wrap up now. I'm going to try and sum up a little bit and ask you if I've missed anything out. So I think we agree that we've got to use the tools we've got. AI is one of the important tools. Smart people are one of the important tools. making sure you take your workforce with you and you use their current knowledge, on the ground knowledge, that decarbonisation projects, they can be cost effective, they can be done immediately, and they don't. And there are really great ways to decarbonise through energy efficient conservation and doing things smarter that don't involve massive capital at the moment. And every little bit helps. It's something now is much better than something in 10 years' time. And the decision support system that you guys talk about, it can embed value in this energy value chain. That good thinking and good processes. And I suppose the other thing for me in summing up is that we have to look at our current industrial processes. We have to make them the most efficient we can before we start going and looking at alternative expensive fuels, because that's going to save us in the long run. And it's also going to get us there quicker, because if you look at the current bill that you would need in hydrogen, you'd look at it and you'll go, oh, we can't afford that. But if you make your energy conservation and energy efficiency project first and then have a look, well, maybe you can. So is there anything else you guys would like to add?
I think you summarized it really well, Jeff.
Yeah.
Okay.
Couldn't agree more. Yeah. Couldn't agree more.
Thank you so much for the interview. Thank you for your time. You actually get the double whammy. You're the only people. You're going to appear on Sim Europe in their live on their virtual conference, but you're also going to appear on Simpac Live, which is my show down here in Australia, to the wider audience down here. We'd love to see you down in Australia at some stage. February is a really nice month to visit the sunny Queensland and get out of your winter if you've got a mind to come down. But thank you very much, and we look forward to seeing you again.
Okay, thanks, Jeff.
Thank you very much, Jeff, for the opportunity. Looking forward to seeing you in better weather circumstances than here. Yeah.